My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject data mining as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is data mining. Data mining means finding useful information from a large amount of data, just like searching for hidden treasure. Companies and apps collect lots of data every day, and data mining helps them understand patterns and make smart decisions. Simple example. Imagine a shopkeeper who notes what customers buy daily. After some time, he sees a pattern. People who buy bread also buy butter. Ice cream sells more in summer. These patterns help him keep the right products in stock. This is exactly what data mining does. It finds patterns that humans may miss. Where it is used. YouTube, Netflix suggests videos based on what you watch. Online shopping shows customers also bought items. Banks detect fraud by spotting unusual transactions. Easy to remember. Data mining is equal to data, lots of information, plus mining, digging to find something valuable. So, it means digging into data to find useful patterns and knowledge. Next important short question is 2 interesting patterns. Interesting patterns in data mining. When we do data mining, we search for interesting patterns, useful relationships or trends hidden inside large data. These patterns help us understand people's behavior and make better decisions. Here are some easy types of patterns. 1. Association patterns. These show what items usually go together. Example, in Big Bazaar, data shows that people who buy tea also buy sugar. So the shop keeps them close together. 2. Trend patterns. These show how something changes over time. Example, mobile data usage increases during festivals because people share photos and videos more. 3. Classification patterns. These help group data into categories. Example, a bank classifies customers as low risk or high risk based on income, spending, and credit history. 4. Anomaly patterns. These show unusual or unexpected data. Example, if someone suddenly withdraws a large amount at midnight, the bank suspects fraud. Easy to remember. Interesting patterns is equal to relations plus changes plus groups plus surprises. Next important short question is 3. Data preprocessing. Data preprocessing means cleaning and preparing raw data before using it for data mining. Just like we wash vegetables before cooking, we must clean data before analyzing it. Why do we need it? Because raw data usually has mistakes, missing values, duplicates, and unwanted information. Steps in data preprocessing, easy to understand. 1. Data cleaning, fix wrong or missing data. Example, if a student's age is written as 250, we correct it to 25. 2. Data integration, combine data from different sources. Example, merging data from a school's attendance system and exam system. 3. Data transformation, convert data into proper form. Example, converting all prices into rupees for consistency. 4. Data reduction, remove extra data and keep only important information. Example, from a 100-column survey, keeping only 10 useful columns. Easy to remember. Data preprocessing is equal to clean plus combine plus convert plus cut. It makes data neat and ready for mining. Next important short question is 4. Why preprocessing? Preprocessing is needed because raw data is messy, just like unwashed vegetables. If we use dirty or incorrect data, the results of data mining will also be wrong. Preprocessing makes data clean, complete, and ready for analysis. Reasons why preprocessing is important. 1. Removes errors. Raw data may have spelling mistakes, wrong numbers, or missing values. Example, a person's age written as 50 instead of 50. 2. Makes data consistent. Different sources may use different formats. Example, one file shows price in rupees, another in. Preprocessing makes them uniform. 3. Reduces unwanted data. It removes extra or repeated information. Example, duplicate entries of the same student in a list. 4. Improves accuracy. Clean data helps algorithms give better results. Example, banks detect fraud more accurately when the data is correct. Easy to remember. Why preprocess? Because clean data is equal to correct results. Next Unit 1. Long questions. First important long question is 1. Explain the kinds of data in data mining. Kinds of data in data mining. In data mining, different types of data are collected from various places like apps, banks, hospitals, shops, social media, etc. To understand and analyze this data properly, we divide it into different kinds. Think of it like organizing your study materials, books, notes, PDFs, so learning becomes easier. 1. Structured data. This type of data is well organized and stored in tables, rows and columns. Example. A school database with columns like name, class, roll number, marks. Bank transaction tables. Why easy? Because computers can read and analyze it quickly. 2. Unstructured data. This data has no fixed format. It is messy and harder to analyze. Examples. WhatsApp messages, YouTube videos, photos, audio recordings, social media posts. Why difficult? Because computers must understand text, images, and videos before analyzing them. 3. Semi-structured data. This lies between structured and unstructured. It doesn't follow strict tables, but still has some tags or structure. Examples. Emails, to, from, subject. JSON files. XML files. Easy way to remember. Emails look messy but still have some structure. 4. Transactional data. This data records day-to-day transactions. Examples. Items purchased in a supermarket. Train or flight ticket bookings. UPI Paytm payment history. Why important? It helps find buying patterns, like people who buy rice also buy dal. 5. Time series data. Data collected over time to see changes or trends. Examples. Petrol price changes every day. Sensex Nifty stock market data. Weather temperature recorded daily. Useful for prediction. 6. Spatial data. Data related to location, maps, or geography. Examples. Google Maps GPS data. Locations of ATMs, hospitals. 7. Multimedia data. Data in the form of images, audio, video. Examples. Instagram Reels. CCTV footage. Medical X-ray images. Easy to remember trick. Structured tables. Unstructured text video. Semi-structured emails. Transactional daily buying booking. Time series time-based. Spatial maps. Multimedia photos videos. Next important long question is 2. Functionalities. Functionalities of data mining, simple and easy explanation. Data mining helps us discover useful knowledge from large amounts of data. To do this, it performs different functions, like finding patterns, predicting future values, and grouping similar things. Think of it like a super smart assistant that studies data and tells you what is happening and what might happen next. 1. Classification. Classification means putting data into categories based on rules. Example: a bank classifies customers as low risk or high risk for loans using income, job type, and credit score. Why useful? Helps make decisions automatically. 2. Prediction. Prediction means guessing future values using past data. Example: predicting tomorrow's temperature, stock market trends, or next month's electricity bill. Why useful? Helps plan for the future. 3. Clustering. Clustering groups data that is similar into clusters. Example: a shopping website groups customers based on spending habits. Low spenders, medium spenders, high spenders. Why useful? Helps in targeted marketing. 4. Association rule mining. This finds relationships between items. Example: in Big Bazaar or D-Mart, data shows people who buy chips often buy cold drinks. Why useful? Stores arrange items based on such relations to increase sales. 5. Outlier, anomaly, detection. Outliers are unusual data points that don't fit the pattern. Example: if your electricity bill suddenly jumps from 500 rupee to 5000 rupees, it is an anomaly. Why useful? Helps detect fraud, errors, or unusual events. 6. Summarization. Summarization means making large data short, simple, and meaningful. Example: a teacher summarizes a class test showing average marks, highest score, weak topics. Why useful? Gives a quick overview of big data. 7. Evolution and trend analysis. This studies how data changes over time. Example: tracking how online shopping increases during festivals like Diwali or Holi. Why useful? Helps understand patterns and plan business strategies. Easy trick to remember. CPCAOSE. Classification categories. Prediction future. Clustering groups. Association relations. Outliers unusual points. Summarization short version. Evolution trends over time. Next important long question is 3. Discuss about data mining task primitives. Explain with example. Data mining task primitives, simple and easy explanation. Data mining task primitives are the basic building blocks or instructions used to tell a data mining system exactly what we want to find. Think of them like giving a food delivery app your order. What food you want? From where? How spicy? How many plates? Similarly, task primitives help us clearly define a data mining task. 1. Task-relevant data. This defines what data we want to study. Example: in a school database, if we want to analyze toppers, we select only name, marks, class, not attendance or address. 2. Kind of knowledge to mine. This tells what function we want to perform. Classification, clustering, prediction, association rules. Example: a shopkeeper may want association rules to find which products are bought together. 3. Background knowledge. This includes extra information that helps data mining. Example: a bank may provide categories like high income, medium income, low income to help in classification of loan customers. 4. Interestingness measures. These help us filter useful patterns from useless ones. Example: if association rule says, people who buy milk also buy bread 5% of the time. This is not useful. But if it's 80%, it is interesting. 5. Presentation and visualization. This defines how we want the results to appear. Tables, graphs, pie charts, bar charts, rules. Example: a company may want sales data shown in a bar chart for easy comparison. 6. Data mining algorithms. This defines which technique or method should be used. Example: for classification, we may choose decision tree, naive Bayes. For clustering, k-means method. Easy trick to remember, TKBIPA. Task relevant data: what data? Knowledge type: what to find? Background knowledge: extra info. Interestingness: useful or not? Presentation: how to show? Algorithm: which method? Next important long question is: 4. Discuss the major issues in data mining. Major issues in data mining. Although data mining is powerful, it also faces many challenges. These challenges make the work difficult, time-consuming, or less accurate. Let's understand these issues in simple words. 1. Data quality issues. Data is often incomplete, noisy, or inconsistent. Example: missing age in a student record. Wrong mobile number. Spelling errors like Amit written as Amita. Bad data is equal to bad results. 2. Huge volume of data. Today, companies collect massive amounts of data every second. Example: Facebook posts, UPI transactions, online shopping data. Handling, storing, and analyzing such large data is difficult. 3. Complex and high-dimensional data. Some data has too many features. Example: medical data with 1000 plus test parameters. More features is equal to more complexity. 4. Privacy and security issues. Data mining uses personal data, so privacy becomes a concern. Example: people may worry about apps tracking their location or bank transactions being analyzed. Companies must protect user data. 5. Data integration issues. Data comes from different sources that may use different formats. Example: college attendance in Excel, marks in a database, fees in PDF. Combining them correctly is challenging. 6. Choosing the right algorithm. There are many algorithms, but selecting the best one is difficult. Example: for classification, should we use decision tree or naive Bayes? Wrong choice may give wrong results. 7. Scalability issues. When data grows, systems must still work fast. Some algorithms become slow with large datasets. 8. Interpretation of results. Data mining produces patterns, but understanding them correctly is important. Example: if data shows ice cream sales increase with sunglasses, it doesn't mean one causes the other, both increase due to summer. Easy trick to remember, QVCPIASI. Quality, volume, complexity, privacy, integration.